So pH of acids and bases. So way back from junior high, hopefully you remember that if you are less than pH of less than 7, you're acidic. And if you're a pH of greater than 7, you're basic. And then right at 7 is neutral. Okay? So hopefully you remember that. And when we're determining if something is acidic or basic, we're always going to look at the pH. Because we're going to learn something today called the pOH. But when we're determining if something is acidic or basic, we're going to look at the pH for that. Okay? And so here's a couple of things just in everyday life that are either acidic or basic. And we talked a little bit about that yesterday. Some of our sour candies we said were acidic. And of course things like soap and stuff are basic. So there's some examples of that. A lot of your cleaning supplies are usually going to be basic. Okay? Okay. So first of all, when we're talking about pH and pOH, up here at the top, if something is in brackets, right here, it means we're talking about the concentration of it in molarity. And molarity we did last unit with solutions. Its concentration is moles per liter. Okay? So when we're talking about acids and bases, we're going to talk about their in terms of their hydrogen concentration and their hydroxide concentration. So the pH scale is going to indicate the hydrogen ion concentration. Okay, and remember we show that as either H plus or H3O plus. What is the name of that H3O plus? Remember I told you you have to know that for a test. Hydronium. Okay.
Hydronium.
H3O plus. We'll write that down because you do need to know that you recognize that as a hydronium. Okay? So basically it's a funny looking name for hydrogen, right? But it's hydronium. So in 1909 is when they first determined the pH. The P in the pH stands for power of hydrogen. And because we're talking about the log scale, that's why it's power of hydrogen. But it was originally discovered to help have the same kind of, it's basically for beer. When they were first started brewing beer on a commercial process, people were brewing it all differently, so they came up with this pH scale so that they could all kind of be the same. Interesting side note. Okay, these are the formulas that we're going to use. This is how we find the pH. We take the negative log of the hydrogen concentration, and let's say we have the pH. Let's say the pH of the solution is 6.7. We can then back calculate and determine what the actual hydrogen concentration is by this formula, which is 10 raised to the negative pH value, and then the answer would be in molarity. If you look at your calculators, you see the log button. Everybody find the log button, okay? When we're typing in, you must type in negative log. Do not type in minus. It has to be the negative button. Otherwise, it will not give you a proper answer on most calculators. The other thing is if you look at this 10, look at the inverse key of the log. What does it say?
10x.
10x. It's called the anti-log, actually, is what it's called. So when you're going the other direction from pH to concentration, you're taking the anti-log. When you're doing it that way, you can either use that inverse key of log, or you literally can do 10 raised to the negative pH in the calculator, the little caret sign. So either one of those would work, but when you're doing a log, it has to be negative log. Okay? So generally the pH scale is from 0 to 14. 7 is considered neutral, meaning I have the exact same concentration of hydrogen and hydroxide. When we're finding pOH, it's very similar, except now instead of a hydrogen concentration, we have OH, the hydroxide. Same formula as negative log. If I have the pOH, I can raise 10 to the negative pOH and get the molarity of the concentration of the hydroxide. Okay? This is very important. I would circle it and star it. Together, pH plus pOH is going to be equal to 14. Okay? So what's cool about this is if I know one of these values, I can find the other three. If I know pH, I can find pOH, and I can find hydrogen concentration, and I can find hydroxide concentration. Okay? Or vice versa. If I know hydrogen concentration, I can find pH, pOH, and the hydroxide concentration. Okay? So, for example, if I have a pH of 2, what is my pOH going to be and my hydroxide concentration?
12.
pOH is going to be 12 because I took 14 minus 2 and I got 12. So in order to find the hydroxide concentration, it would be 10 raised to the negative 12. And if you were to do that in your calculator, it's basically this. Okay? Now, if you have a whole number, you can just leave it like that. If it is a decimal, you have to plug it into your calculator. Okay, you can't leave it if it's a decimal. Now, a little note about significant figures. They are a lot different when we're doing PHs. Okay, the only numbers that count as significant are the numbers that come after the decimal. So, for instance, if I had a pH of 12.01, I would have 2 decimal or 2 significant figures. If I had 12.0, I would have 1. So technically, when I do it like this, I actually have 0 significant figures. So this is why that would actually be considered accurate. Okay, but a lot of people get confused by that. That is the same thing as this. Okay, they mean the same thing. Okay, so we're going to do a couple of calculations today. Okay, so everybody have your calculators handy? Okay, so in the first one we have a 0.1 molar HCl. Find the hydrogen concentration and the pH. Okay, well, it gave us the hydrogen concentration right here. Sorry, I forgot to hit the button. So that is actually our hydrogen concentration. So we would say hydrogen is equal to 0.1 molar. And that's because when that breaks apart, remember HCl breaks apart into H plus Cl minus. And so since it's 0.1 here molar, it would be 0.1 for hydrogen, and it would also be 0.1 for chlorine. But we don't care about the chlorine. So in order to find the pH, we're going to take negative log of 0.1 molar. So someone do that for me. And this has 1 significant figure in it. So when we report our pH, we're going to report it to 1 decimal place. So someone do negative log of 0.1. So you would write it as 1.0. Okay? Because we have to include that 1 significant figure from the original. Okay? The next one gives us a concentration of 4.0 times 10 to the negative 3. That is the concentration. So we would just say that's the same thing as that. And then to find pH, we would say negative log is equal, pH is equal, sorry, to negative log of, let me erase that, 4.0 times 10 to the negative 3. And what do we get with that? Anybody? Okay, but I need 2 significant figures because this has 2. So 2.40 would be my pH. Okay? See how that works with the sig figs?
Wait, I thought it only had 1.
Oh no, but this up here has 2. Whoops, sorry.
I just said that only the one after the decimal.
Oh, but that's for pH. This is not a pH. This is an actual number. Okay? So this has 2. When we're talking sig figs on the pH, we're talking about the pH value, not the concentration value. That's normal sig figs rule. Okay? So because this has 2 right here, when we report our pH, we have to have 2 decimal places behind it because of the 2 sig figs. Okay? Is that clear now?
Sure.
Okay. Sure. So let's do number 4. Okay? This time we have the pH, okay? And we need to find the hydrogen concentration. So we're going to say it's equal to 10 raised to the negative pH. So we would say 10 raised to the negative 2.56. We cannot leave it like that. We actually need to type it in. Okay? Now, we have 2 significant figures in the pH. So when we report our concentration, we're going to report it in 2 significant figures. So do 10 raised to the negative 2.56 and tell me what you get.
0.00275.
Let's put it in scientific notation.
Okay, 2.8 times 10 to the negative
Negative
3.
To the negative 3
Yeah.
molar. Okay, just remember it is a concentration, so we need to put a unit on it. Okay, and so it's the same concept for these other ones we didn't do. But I want to show you something else that'll show up, and sometimes people get confused. So if I have a problem such as this, okay, hold on, my thing's giving me problems. Here we go. So let's say I have a solution that is 3.41 times 10 to the negative 2 molar NaOH, which is what? An acid or a base? Base, because of that hydroxide. This is basic, okay? Or this is a base. We don't know if it's basic yet, okay? So I need to find pH, and I want to find the hydrogen concentration. Sorry, that does not look like I wrote hydrogen. Okay, so I can take the negative log of this, but what would I be finding? pH? If I take the negative log of that number? Because it's a concentration, what would I be finding? I would be finding POH. Okay, because that is a hydroxide concentration. So I would need to take the negative log of that. So let's do that. And what do y'all get? Say that again. 1.467. Good job on putting enough sig figs on that pH, or POH rather. So now that's my POH. So now I would go pH is 14 minus that number. And I would get that my pH is now 12.533. Okay? And now I could find my hydrogen concentration by taking 10 raised to the negative 12.533. And I would get 2.93 times 10 to the negative 12 molar of hydrogen. So would this solution be acidic or basic? I'm sorry, what? I'm sorry, what? I can't hear you.
Mine says it's -13.
What's negative 13?
Times 10 to the -15.
Oh, mine says 13 too, but I had taken my glasses off. Sorry. Yeah, I took my glasses off before I finished reading it. It is negative 13. Yeah. I should just leave them on all the time. I need to go to the eye doctor. They canceled my appointment. Okay? So this solution, because of pH, because we look at the pH value to determine acidity or basicity, this would be a basic solution. We would call this basic. Yeah, it's hard to say base. You can say acidity. It's hard to say basicity. It sounds like I'm saying basicity. Yeah. Yeah. Basic. Okay, so this solution would be basic. So when you're looking at that, that's what you're going to use to determine that. When you're doing your worksheet today, when it asks you at the column, I think the last column says acid or a base, we look at our pH, not our pH, to determine that. Okay? 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 So we already did these examples, and then we're going to talk about buffers later on. Okay? So we'll start, well actually let's go ahead and talk about buffers real quick. Okay? No, I'm awake. I changed my mind. We'll talk about that later.